This is Unit 8, Day 10, Shifting Functions for Algebra 1. I am going to apologize up front. Apparently the PDF for this file did not save correctly, so we're going to have to make some fixes as we go through, and that includes having to fix some of the problems on the homework. So when you are done with this video for the lesson, please continue it on so that I can show you what fixes to make in the homework. Basically what happened is it took all of my exponents and didn't put them in the air. So we're going to have to change all our exponents. So the shifting functions, the basic ones is quadratic, so the 2 needs to be in the air. And the basic form of a quadratic is x minus h squared plus k. And it says h and k are the vertex, and we'll get into that a little bit. Exponential function, again, that little x minus h should be in the air. Okay, a is whatever base, it's going to be some number like a 2 or a 3. And then x minus h is your exponent in the air plus k. Keep in mind, they do not have to put the exponent in parentheses. The fact that both of those are little and raised means the h goes with the x anyway, so you might see it without the parentheses. Again, so h and k is the horizontal shift and the k is the vertical shift, which in a quadratic and an absolute value equation is also your vertex. The absolute value equation is correct the way it is written. Alright, so yesterday, or the last lesson, you had a discovery lesson where you graphed a parent function and then you graphed another function to see what putting different numbers into the equation would do as far as shifting. And then you had some homework to describe that shift. So that we're going to review that right now, but we're going to go and fix the quadratic. So for question number 1, there should be an exponent of 2. For question number 2, the exponent should be x. For question number 4, the exponent should be 2. And that's it. Alright, so name the shift in the following functions. So the basic thing you've got to remember is that whatever number is grouped with the x, it ends up looking like it shifts the opposite direction. And that's because in every single one of those formulas at the top, there is a minus sign with the x. The minus sign stays with the formula. You're only plucking the number off, which is why it makes it look opposite. All right, so whatever number's with the x is the horizontal shift in the opposite looking direction. Whatever is outside the x is your y shift, your vertical shift, and that goes the way it appears. So for number 1, I see a 5 paired with the x, so that means it's going to go left instead of right, 5. And then the outside number is the 6, and it does what it says, so it goes up 6. Okay. For number 2, you have 3 to the x, which is, there's nothing paired with the x. X is the only thing in the air, so there is no horizontal shift. This plus 1 is not touching the x, so that means we're going up 1. Number 3, the number paired grouped with the x is you have a minus 3, so when it comes out, it's a positive 3, so we're going right 3. And then the number outside is 8, so that's your vertical shift, up 8. For number 4, we have an x squared. There is nothing paired with the x. There is no horizontal shift. Plus 5 is out here by itself, so the plus 5 means we are going up 5. For number 5, okay, the number paired with the x is a positive 4, so when it comes out, it's a negative 4, meaning that we're going to go left 4 places. And then 6, 7, and 8 are in a notation that we have not yet seen. And they use this notation quite a bit on the Regents exam. So f of x is a function. Any function. It can be any equation that the authors want, and they're not going to tell you what that equation is. Okay? And it doesn't matter, because no matter what equation you start with, if you add or subtract something to the x, that function is just going to shift horizontally. And if you add or subtract something on the outside, then it's going to shift vertically. So we don't care what the function is. All they want to know is, how does their mystery function shift? Well, you have a plus 2 in with the parentheses, which means it's going to be a horizontal shift because it's paired with the x and the opposite direction it appears. So this function is going to shift left 2. I don't know what function it is. I don't know what it looks like, but I don't care. All I know is their original function is going to move left 2 places. So same thing with number 7. The negative 3 is outside of the x, which means it's a vertical shift. So whatever their mystery function is, it's going to shift down 3. And then number 8, we have a negative 5 in with the x, so that's the horizontal shift in the opposite direction it appears. So we're going to go right 5, and on the outside, up 2. So whatever their mystery function is, it's going to go right 5 and up 2. All right, number 9. Given that f of x is equal to negative 3x plus b, what would happen to the graph if b were decreased by 3? Since b is not paired with the x, that makes it a vertical shift. So if you take any number and lower it by 3, vertical shifts go the way they appear. So if you're going to decrease the number by 3, it is going to shift down by 3. Okay. Number 10, that little 2 is supposed to be in the air. So if h of x is equal to x plus a squared plus 6, what would happen to the graph if a were increased by 4? Well, if you're not sure, you can pick an a right now, and let's say this was x plus 3 squared plus 6, just for grins and giggles. So if this a happened to be a 3, that would be a shift left 3 places. So now it says, what if you increase a by 4? So now it would be an x plus 7. So that would be a shift left of 7. So what happened? You just went left 4 more places than you did to begin with. First I went left 3, then I went left 7. So I went left 4 places. And if you think about it, it should make sense because whatever is in with the x goes the opposite direction. So if you're going to increase by 4, you're going to go left 4 more places because it always goes opposite of what it appears. All right, this little cube is supposed to be up in the sky. So if j of x is equal to x minus q, in parentheses, cubed, plus p, what would happen to the graph if q were decreased by 1 and p was increased by 3? Well, let's deal with the q first. The q is decreased by 1. So the q is a horizontal shift. So decreased by 1 seems to indicate that we should go left 1. But because it's with the horizontal shift, we know it goes opposite, so it's going to go right 1 place. And if p were increased by 3, that's a vertical shift, and it does what it says, so that it goes up 3 units. Okay, and if you don't like it with the q's and the p's, you can make up your numbers for q and p, and then change it and do what it says, and just check that that's the way it goes. These are actually reading questions now. The minimum point on a graph of the equation f of x is -1, -3. So that's the lowest point on whatever graph it is. Don't care what kind of graph it is, don't need to know. What's the minimum point on the graph y equals that same function plus 5? Well, to have a plus 5 on the outside says it's a vertical shift. Vertical shift says it's going to go up 5 units. Well, up is a y direction, so I am going to add 5 to the y value of my coordinate, and that puts me at -1, 2. Okay, you could always grab a piece of graph paper, graph this point, move it up 5, and see what the coordinates are. That's the other way. 13. The maximum point on the graph of the equation y equals f of x is 2, -3. Again, we have a mystery function, but we know the maximum point is this. What would the maximum point on the graph of y equals f of x minus 4b. So they're taking that mystery function and we're shifting it horizontally. Well, because they put a minus 4, that tells me that I'm going to go right 4 places. Again, you could take a piece of graph paper, plot that point, move right 4 places, and tell me what the coordinates are. But going right is a positive direction, and it's an x direction. So I'm going to add 4 to my x coordinate and get 6, negative 3. So there's a piece of graph paper down on number 14. Give it a shot. Number 14, the graph of b of x is shown below. H of x, so some new function called h of x, is found by taking the function b of x and performing this transformation to it. So what they're telling you to do is to shift the function b of x, and when you get done shifting it, we're going to give it a new name called h of x. Alright, so it has a minus 2 in with the x. That means we're going to shift this function right 2. Negative 3 is on the outside, so we're also going to go down 3. And they want us to graph this new function called h of x. So all I need to do is take each point on the graph, each nice point I can find, shift it right 2 and down 3 and draw another one. Now be careful because, like I said, these are Regents questions. And we had the situation on our Regents when we were grading where people only shifted these 3 points, and then when they drew their parabola, it kind of got a little too wide too fast, and they docked them a point for not being accurate. So what you want to do when they give you a graph is take every nice point and shift it. So here's another nice point right here and right here, and you really need to shift all 5 so that you draw this properly. Alright, so right 2, down 3. Right 2, down 3, and then take the next point, right 2, down 3, right 2, down 3, right 2, down 3, right 2, down 3, and make yourself a new U. And with those 5 points, we will be more accurate. Don't go too far with your arrows, and make sure you label it. Anytime you have 2 graphs on a grid, you must label at least one of them. Otherwise, Regents will dock you. So I'll put the b of x there as well. Alright, so we took their function b of x, shifted it, and we gave it a new name called h of x. Alright, this was a multiple choice question that showed up on the Regents. Alright, we have a graph f of x, okay, which looks like a nice little parabola. Which one represents f of x plus 2? So the plus 2 is in parentheses, so that's a horizontal shift. Horizontal shifts go in the opposite direction. So we want to shift this thing left 2 places. The easiest point on a parabola to shift is the vertex. So I just want to make sure the vertex ends up over here 2 places to the left. So I'm kind of looking for something like that. Graph number 1 goes to the right. Graph number 2 goes to the left. This one's our winner. Alright, so I told you that at the end of the notes to keep the video going so I could fix the homework questions, and that's what you need to do. So sketch the following. The first one, that little 2 should be up in the air as an exponent. The second one should be an x plus 2 as an exponent. Probably can tell because they're little. I don't know why it's saved this way. I've not had any other issues with any other worksheets. Alright, scrolling down. Number 1 should be a square. Number 2, the x minus 1 should be in the air. Number 4, the x plus 4 should be in the air. And number 5, the square should be in the air. Number 10, the x plus r should be in the air. Number 11, the 4 should be in the air as an exponent. Number 12, the little 3 should be in the air. And that might be it. Yeah, the rest are Regents questions. Okay, give the homework a try, and good luck.